My name's Daryl Faulkner. I've been an architect with Mix for quite a while now, and I'm going to be talking about z13 multithreading and something you can do in ZOS 2.1, even if you're not doing multithreading, that will break Mix, and it's called ProcView Core. So in Mix, we have 4 files that we create from the SMF Type 70 CPU activity record. 2 of them, the HARLPC and the HARVPA, they come from sections in the Type 70 record that talks about every LPAR in your system. It talks about VM LPARS, ZOS LPARS, coupling facility LPARS, and so on. The HARVPA file has an observation in the detailed time span for each RMF interval for each one of those logical cores that you've assigned to each one of those LPARs. And the HARLPC file contains 1 record per detailed time span RMF interval for each one of those LPARs. These 2 files deal with cores. The HARCPU and HARIPU file, however, deal with processors. And processors we'll talk about a little more, but processors or threads are very much part of this whole SMT thing. But within all 4 of these files, we have a huge, huge set of common elements that all begin with the characters PRSM, prism this, prism that. And it defines the KEK configuration, how many physical cores of each type are found in the entire KEK. It basically, what's the minimum, max, and so on. It defines the box that the KEK that you bought, CPC you bought from IBM. So the very first major update with RMF 7060 is we are relabeling and updating the dict text for all the prism elements that used to say processors, and we're now making it clear that this is talking about cores. So you can see this is just from RMF Gen in a bunch of common element definitions for a bunch of these prism elements. You can see that they all used to say number of processors, number of this processors, number of that processors. We're relabeling them and updating the dict text to say we're talking about cores. So that's a big impact of RMF 7060. We're going to change the labels and the dict text for all of these elements. The content won't change. The content in the database files, when you look at the number, you're going to, if it said 10 shareable processors yesterday, and you look at the PRSMT CSP element tomorrow after RMF 7060, and you look at the value, it's still going to say 10. But it will now say it's 10 shareable cores in the label, and the dict text will explain that we're talking about cores. The HARVPA file, which is the file that talks about each one of those logical cores you've assigned to your LPARS, its name is changing. It's now the logical core activity file, not the processor activity file. And I really like the HARLPC file because when you're trying to look at total, for example, MSU utilization, million of service unit utilization for a KEK, you need to look at how many MSUs each one of your LPARS is using, not just your ZOS LPARS. And that information, which ultimately comes from dispatch time of each of those logical processors to the physicals across all your LPARS, that's found in these files. So they're good files to use, but all of the information in these 2 files is core level. The Type 70 record, the parts of the Type 70 record we used to build these 2 files did not change with multithreading. And the data is at the core level. So the second major update that you're going to see with RMF 7060 is labels and definitions for HARVPA and LPC file elements are clarified to make sure we're talking, to make sure you know we're talking about cores. Now, The big impact on multithreading, at least for the RMF component, is for these two files, the HARIPU and HARCPU files. These files are built from sections in the Type 70 record that are only applicable to ZOS LPARS. So it's ZOS LPARS cut RMF data, and each LPAR, sys1, will cut Type 70 records, and it has information about itself in addition to those other sections that talks about all LPARS. It has information just for its ZOS image. Historically, if you had the ZOS LPAR sys1 defined, the ZOS LPAR defined that I have on this page, it has 3 CP cores and 2 zip cores. Every RMF interval in the detailed time span of the HARIPU file, you would get 5 records. You would get 3 records for the CP engines and 2 records for the zip engines. Each one of them has an IPU adder, IP address, and it gives you all the information about ZOS's use of that core. With SMT activated for zip cores, for ZOS, IBM only allows multi-threading on zip cores in the initial delivery. ZOS is not going to see 2 zip cores to dispatch your TSO session 2 or your batch job. It's going to see 4. It's going to see 2 processors that it can dispatch work to. And they're going to have unique thread addresses. This SMT world, the term thread and processor is analogous. Those terms are analogous. So ZOS, when you turn SMT on for this sys1 LPAR, he's going to continue. He always did. He's going to see 3 CP processors that he can dispatch CP work to, but he's going to see 4 zip processors he can dispatch work to. Each time one of those zip processors gets put on a physical processor by Prism for sys1 to do stuff, ZOS is going to see 2 processors he can dispatch at ready work to. Your TSO session is ready. He could dispatch him to the zip0 processor or the zip1 processor. So that's a big change. And to deal with that, the cores have an IPU address. And that was a summarization key, always has been in the HARIPU file. We've relabeled that summarization key to say processor core address. And we've added a new summarization key called processor thread ID. And in mix, this will always have a value of 0 or 1. If you're running single-threaded, and let's say you have a ZEC12 and you're at ZOS 2.1 and you apply RMF 7060, nothing's going to change for you. You're going to have a single record per IPU adder per detailed time span for each engine that you've, or excuse me, each core you've assigned to a LPAR. The thread ID will always be 0. The only time you will ever see 2 records for the same IPU adder is if you have a Z13 and you have multi-threading active. And in that case, you'll see one record that has a thread ID of 0 and another one that has a thread ID of 1. So this is a big impact on the HARIPU file. We have a new summarization key, IPU thread ID. We have to retrofit your existing IPU file observations and stick 0 in there as the thread ID because that's what you have. You just have, without RMF 7060, all you have is 1 record per IPU adder. You cannot get 2 until you activate multi-threading. So we retrofit your file, and again, big documentation effort. We update elements in the IPU file to clarify which are core and which are processor. The IPU file for ZOS LPARS is really a superset of the HARVPA file. Remember, the HARVPA file has prism-level core information for all LPARS, including sys1. But for sys1, we have some additional information, which is processor level, which is now in the same HARIPU file. So we need to make it clear which elements in the HARIPU file are core level because we got them from that prism area, and which ones are processor level because we got them from the updated data that we get with SM2. And just to clarify this is a printout of data we have from a multiprocessing environment. What you're looking at here at the top and bottom are two different IPU adders. So these are two zip cores. The top one has a IPU adder value of hex 2 Charlie, and the bottom core has an IPU adder address of 2 dog. So what I have shown here is 4 intervals for each of them. And you can see, if you look at the start timestamp, you see 2 identical timestamps for each interval. And what you're seeing is the first one of the pairs is thread 0, and the second one is thread 1. These are 10-minute intervals. So you can see that IPU online time is 10 minutes for each of those. So we need to make it clear that IPU online time in this file is a processor level value, not a core level value. Each one of these threads or processors was online for 10 minutes. They were up for 10 minutes. The percent IPU busy, this is the dispatch time that the core was dispatched. And in both cases, it was 0.39% busy, meaning it was dispatched during the 10-minute interval 0.39% of the time. But the final value is this. This is from ZOS's perspective. This is how busy the thread was. And if you notice, you add those two numbers together, 0.36 and 0.09, it's greater than the busy time that the core was dispatched. So you can see that you can actually get more work done between the two threads than could have been done with just the time that a single thread was dispatched. So with multi-threading, you still get all of the Prism busy and NVS busy values that you always did, but IBM has introduced some new concepts, maximum core, maximum capacity factor, actual capacity factor, thread density, core productivity. These are values that let you determine how efficient your multi-threaded cores are. And at the detail level, it's not that big a deal to show these values, but with mix, we summarize data. For example, we show you detailed data, but we also show you days level data where intervals are summarized to the hour level. And it turns out that when you want to see what these factors were at an aggregated level, you need to weight them by a thing called core busy time, which is a new time value that says for this core during the interval, how much time was there when at least one thread was doing something. So it's usually a little smaller than dispatch time, but you have to weight each one of these factors by the core busy time so that when you aggregate them to a summarized level and show these computed elements, these averages, you have to divide out the thread busy time factor. But what that means is that threads that were active for longer periods of time, or cores that were active for more active than other zip cores, their factor values provide more of a impact on the overall average. So anyway, you're going to have these new values in the HARIPU file. In the HARCPU file, we aggregate together all of the core level information for the LPAR, for ZOS LPARS. And we have sets of elements. We have elements that show information for the CP cores, for the zip cores, and for the ZAP cores. And by the way, with the Z13, there's no more ZAPs. IBM is phasing ZAPs out. With the Z13 for ZOS, well, for anything, you can only have CP cores and zip cores. So ZAPs are going away, but we need to support ZAPs for the time being because you might not have a Z13, you might be in an older release of ZOS, and so on. So we have all these ZAP elements instrumented for the time being, but at some time in the future, we're going to have to get rid of ZAP elements because it's a technology that's going away. Anything you could do on ZAP cores, you can now do on zip cores. So zip cores do both the enclave work as well as the work that was done on ZAPs. So in the HARCPU file, we aggregate all that IPU level information. We had an element historically that was CPU number of CPU, and it said it's the number of configured processors, and it still is. But when you look at the data from that ZOS LPAR that had 2 zip cores with SMT activated, this value in this element now says 4 because there's 4 processors configured. When you have SMT active, ZOS is going to see 4 processors dispatch work to. So we've also added a new element called CPU in core, which is the max number of configured cores on this LPAR. All the previous existing busy percentages, MSUs, averages, they're all still accurate. They still mean what they did. We just need to clarify in the doc whether or not you're looking at a core or a processor. We've added the same elements that we added to the IPU file to the CPU file, but we had to do 3 sets of it because, again, a single CPU file observation shows the activity for all the cores for that ZOS LPAR. So we have to show information about CP cores, ZAP cores, and zip cores. Again, ZAP is here for compatibility reasons. The Z13 and going forward, we don't expect to see ZAP cores anymore. So these are accumulated elements, and then these are the averages that you can look at to find out how efficient, how well your workloads are operating in productivity mode. And then finally, I'm wrapping up here. There's a pretty big change to the CPU activity report. There's some new sections and factors that IBM is reporting in the first page of the CPU activity report. And I'll talk a little bit, I'm going to show an example of the report. By the way, if you search the web for Z13, SMT, you can find some really good share presentations that explain a lot of these factors and values in some detail. So this is what the multi-threading IBM CPU activity report looks like. And the 2 large boxes are brand new. The report used to go MBS busy, parked, logical processor share, I/O interrupts. They've inserted this empty percent between a couple of previously existing values, and they've added this new thing called multi-threading analysis at the bottom. So if you are not running multi-threading and you've done this thing to your site that tells IBM to generate Type 70 records with the new format, you will get this look to your IBM CPU activity reports, but in all cases, it will look like the CP processors up here. You'll always see 100% here, always see 100% here. You won't see 2 lines per zip. You'll just see one because you're doing single-threaded. And down here, you'll see 1.0, 1.0, 1.0, 1.0, 1.0, 1.0. When you turn on multi-threading, however, the information you see for zip processors is different. And down here, you'll see numbers other than 1. And over here, you'll see numbers other than 100%. So here, you can see that this is the dispatch busy, the 26.03. This is a core ID, a zip core of 2 Charlie and 2 Dog. It was online 100% of the time. The LPAR busy, that's the Prism dispatch time, basically, effective dispatch time. But now we see 2 values under MVS busy. We see the busy time for thread 1 and the busy time for thread 2. So that's going to be different. You're going to see the busy times of each thread as opposed to just a single value like you used to see in the past or like you see up here for the CP processor. Down here on multi-threading mode, you'll see a 1 or a 2. If it's multi-threading, you'll see a 2. This max CF is the max productivity that IBM has determined that you could squeeze out of zip processors or each processor type, core types across all the cores. And in this case, IBM is saying you can get 1.438 productivity maximum. That means basically 144% of workload throughput than you could if you were running single-threaded. That's the maximum potential. The CF is what you actually achieved. And this average thread density is the average number of threads that were active at any time during core busy time. So on average, you had 1.1 threads active. You did not really get very close to this maximum CF. Over here, if you look at the single-threaded, you'll see this 5.73. It exactly matches the LPAR busy time. And basically, the productivity percentage is multiplied against the LPAR busy time. And if you're running single-threaded, you're 100%. If you're running multi-threading, you can fail short of achieving what you could have. And this 74% you see here is roughly the ratio of what you achieved versus what was possible. And the thread density comes into play as well. But this number is multiplied against LPAR busy, so 0.7471 times 26.03 is 19.45. So this shows your utilization percentage is a good way that you can evaluate how well you are utilizing a multi-threading environment. There's a lot of good information on the web from IBM presenters that share that go into this in more detail. And I want to show you real quick, this is an IBM RMF60 generated report sample from the exact same data, and we exactly match IBM's results. Okay, I'm going to wrap up real quick and tell you what we have for you to deal with multi-threading and the Z13. Even if you don't turn multi-threading on, if you're at ZOS 2.1, and I think this is out of the box with ZOS 2.2, but with ZOS 2.1, you can apply an APAR, OA44101. And that enables some settings for a sys1 parm-lib member, LoadXX. There's a proc view parameter supported in that member. The default is CPU. And if you leave the default alone you apply this APAR, you don't change the ProcView parameter, everything will work the way it always did. I think part of going to multi-threading, you have to change ProcView to core or core, CPU OK. When you do this, it tells IBM RMF to change the Type 70 records and put some new sections in there that are in support of multi-threading. Now, if you are running single-threaded and you change this parameter to ProcView core or ProcView core, CPU OK, you're going to change the Type 70 records, even though you're running single-threaded, and MIX will break. MIX will not be able to properly associate all those sections in the Type 70 records. So you need RMF 7055 if you do this. And what RMF 7055 does is it understands the new Type 70 format, and it introduces the concept of IPU-TID 0 and 1. Because you're running single-threaded, every one of your records will have a thread ID of 0, but this will fix the problem that you broke, that broke MIX when you said, I want my Type 70 data and my CPU activity reports to be able to deal with multi-threading, even though I'm not running multi-threading. So if you want to change that ProcView core, you need RMF 7055. We do not provide any of the multi-threading support with 55. We just make MIX continue to work as it used to. With RMF 7060, which we have working here, but we're in the process of packaging and working on the documentation, it will supersede RMF 7055. You could go directly to RMF 7060 and skip 55. Enormous documentation updates. We provide all those SMT-related fields. We update our CPU activity report. We also add a multi-threading enhancement to the HAR, CME, CML, and CMT files. I know some of you have applied RMF 7035, which provided the hardware instrumentation support for 113s from Z13. Well, there's a new counter type, just a couple of them for multi-threading. So this RMF 7060 will incorporate those new counter types that are multi-threading related. And we update the RMF level. If you run data from ZOS 2.2 through MIX today, it's going to say, I don't understand the RMF level. So 60 will update that as well. So we're currently packaging this and doing our final testing, and please let us know if you have any imminent plans to go to multi-threading. I just want to mention two more things. Number one, from ZOS, CPU times do not change with multi-threading. All CPU times reported by RMF are in single-thread equivalent mode. So according to IBM, you do not have to change anything with accounting and chargeback. You don't have to change anything related to performance analysis. You're going to see the same, they are reporting the same CPU times from multi-threaded workloads that would have been reported if they were running single-threaded. What you should see on your zips is a little more throughput, but at least for ZOS, IBM says they are taking care of the CPU times, and you won't have to do any adjustments to CPU time analysis or charging based on multi-threading.